In this video, we're going to look at derivatives of the sine and cosine functions. So two important formulas that we're going to see in this video. First formula is how to take the derivative of sine x. So the derivative of sine x is equal to cos x. And second important formula, the derivative of cos x. I'm just going to fix my handwriting here. So derivative of cos x with respect to x is equal to negative sine x. So when we take the derivative of sine x, we're getting something positive. When we take the derivative of cos x, we're getting something negative. Now, probably a good idea to do a quick recap of our chain rule before we get into our examples, because many of these derivatives involving sine and cosine will have chain rule involved. So let's look at this item here. Okay, let's think back to our chain rule. So we're trying to take the derivative of an inside function raised to a power. So we'd say the outside function here is the function that squares something, and the inside function is the 1 plus 4x. So the chain rule works by you take the derivative of the outside function first. So the 2 would come down in front. Maybe I'll just highlight this in red. So the 2 would come down in front. The power would decrease down to 1. We usually don't write that. Keep the inside function the same, and then multiply by the derivative of the inside function. So if you're not really that confident with the chain rule, you could go back and watch our previous video on the chain rule before heading into this section if you want. Okay, so let's do two quick examples of how the chain rule might actually come up in this section here. So let's imagine we're trying to take the derivative of something like sine x squared. Okay, so the outside function is the sine, and the inside function is the x squared. So according to the chain rule, we're supposed to take the derivative of the outside function. So we'd say the derivative of sine is cosine. Keep the inside function the same. So we write cos of x squared, and then multiply by the derivative of the inside function. So derivative of x squared is 2x. Okay, then from a notational point of view, if we have an x or an x squared or something like that multiplied by a trig function, we usually write those terms at the beginning because it's just easier to read. So just from a notational point of view, we rewrite that as 2x cos x squared. Okay, let's try one more short practice of the chain rule. So I'm just going to put a box around this one, and let's look at one more example here. So let's compare what we just did here with a different type of function. So now we're going to take the derivative of sine squared x. Okay, well, this is where our trig review comes into play. One of the most important pieces of notation when it comes to trig functions is that when you write something like sine squared x, that is really shorthand notation for saying figure out the value of sine x and then square that. So in a similar way, if you had something like tan cubed x, that means figure out the value of tan x and then cube that. So basically that's what's going on here. When we say we want to take the derivative of sine squared x, we're immediately going to say, well, let's just rewrite that before we take any derivatives. So sine squared x is the same thing as sine x all squared. And this way it's really clear what the inside and outside functions are. So the outside function is the squaring function, and the inside function is the sine x. So to take our derivative then, we take the derivative of the outside function. So the 2 would come down in front. Our inside function, the sine x, would stay the same. Technically, that sine x would now become to the first power, but we typically don't write that down. Not mathematically necessary. And then you multiply by the derivative of the inside function. So you'd say derivative of sine x is cos x. So I would say going into some of our bigger calculations today, quite important to be able to tell the difference between this situation and that situation. So if you're taking the derivative of sine x squared, sine is your outside function. Whereas if you're taking the derivative of sine squared x, you would rewrite that as sine x all squared, and then you'd say, oh yeah, the square is my outside function. So with that little preview in mind, we're going to do some calculations involving derivatives of sine and cosine. So the problem is to find f prime of x, and we're going to do 5 little parts here. So part A, f of x is 4 times sine of 7x plus 2. So we'll say, okay, that 4 is just a constant that stays out in front. Take the derivative of the sine function to get cos, keep the inside function the same, and then multiply by the derivative of that inside function, which is 7. And then just to clean that up, the 4 and the 7 would get multiplied together. So you'd have 28 times cos of 7x plus 2. F of x is cos to the 4th x. Okay, anytime we see this situation where we've got a power on the trig function, I would be very careful about just rewriting that as our first step before we do any derivatives. So this means figure out the value of cos x and then raise that to the 4th power. So from there, let's think about what our derivative would look like. So we want to deal with the 4th power first. The 4th power comes down in front, inside function stays the same, power decreases by 1, and then we multiply by the derivative of our inside function. Derivative of cos x is minus sine x. Okay, so then to clean that up, normally the trig functions with the lower powers are written earlier in the expression. So we would get our coefficient by multiplying the 4 and the minus 1 together. We'd say it's minus 4, then we write our sine x, and then that cos x all cubed can be written as cos cubed x. So minus 4 sine x, cos cubed x, I would say is the most conventional way to write that. Part C, let's say f of x is cos squared of 1 minus pi x over 2. So again, this is a situation where a rewrite is probably a good idea. First thing I would do is I would say, well, that's really the same thing as the square of cos of 1 minus pi x over 2. And then we can think about our chain rule. So let's think f prime of x. Okay, we're going to deal with the square first. So the 2 will come down in front. All the stuff in the brackets is now raised to the 1st power. So technically, I don't need that 1st power on there. We keep the inside function the same. So that is cos of 1 minus pi x over 2. Okay, and that means the square brackets aren't really necessary here. So we've just got 2 times cos of 1 minus pi x over 2. And we still need to multiply by the derivative of the inside function. So maybe it was actually helpful to have those square brackets on there after all. So this is our inside function. We need to multiply by the derivative of that thing. So derivative of cos of 1 minus pi x over 2. Okay, so let's just run through that part again. So we took the derivative of the square, 2 came down in front, power on the brackets decreased to 1, kept our inside function the same, and then multiplying by the derivative of that inside function. Now, when the derivative is complicated like this, I'm usually inclined to spread this out over 2 steps. So let's do a second step here. This is where we start to clean this up. So we can say 2 times cos of 1 minus pi x over 2. This is a good time to remove those square brackets. And then let's give ourselves square brackets here, and we're just going to work on finding this derivative here. So there's another chain rule involved. Anytime you've got something more complicated than just a single x inside your trig function, you're going to have a chain rule. So if you have cos of blah, where blah is anything other than x, then we want to think chain rule. Okay, so the outside function is cos. Derivative of the outside function is minus sine. Keep the inside function the same. And then multiply by the derivative of the inside function, which is this stuff here. Okay, so we basically got a number. When we take the derivative of that, that goes away. And then we need to think, what's the derivative of minus pi x over 2? Well, the derivative of 3x would be 3, derivative of 4x would be 4, derivative of negative pi over 2 times x would be negative pi over 2. So we're just pulling out whatever the coefficient of x is as our derivative. Okay, that's a tricky one. There's a lot going on there. So to simplify this, let's multiply the 2 times the negative 1 times the negative pi over 2. So that's going to give us positive pi. And then we've got pi times cos of 1 minus pi x over 2 times sine of that same angle. Sine of 1 minus pi x over 2. So that's how it would likely be written. So bottom line with this kind of problem, try to just do one thing per step. So in the first step, we took the derivative of the square, kept the inside the same, and then we said, okay, we'll take the derivative of the inside function in the next step. Then in the next step, we concentrated on that second chain rule. So continuing to take derivatives here, now we have a product. We have x times cos of 7x. Let's do our product rule. So we're going to take our first factor, x, and multiply by the derivative of our second factor, which taking the derivative of cos 7x, you'd say, well, derivative of the outside function is minus sine of 7x, and then multiply by the derivative of the inside function. So derivative of the 7x would just be 7. So that's the first half of our product rule. Then we go the other way around. We take our second factor, cos of 7x, and multiply it by the derivative of our first factor, which is just 1. And then we can clean this up. So things that would be written towards the front would be the minus 7x. So the x, the minus 1, and the factor of 7 all go to the front. So I have minus 7x times sine of 7x, and then plus cos of 7x. So that's a little bit of practice with the product rule. It's been a little while since we've seen that. And let's do a quotient one as well while we're at it. So let's say f of x is sine x over 1 plus x squared. So maybe over on the right side here, I'll just review our quotient rule. So if you have u over v and you want to take the derivative of that, v u prime minus u v prime over v squared. So we'll start with our denominator, the 1 plus x squared, multiply by the derivative of the numerator, which is cos x, and then we subtract off our numerator, sine x, times the derivative of the denominator, which would be 2x. Okay, and then that all goes over the denominator squared. So in terms of simplifying this, the rule for simplifying quotients is that you want to keep the denominator factored, just like that, and then you want to expand out the numerator. So expanding out, we're going to have 1, 2, 3 different terms in the numerator. So we'll have a cos x, we will have an x squared cos x, and then our last term, we would normally write the 2x before the trig function, so we'd write minus 2x sine x. And that gives us a simplified version of our answer. So the very last thing we're going to do is we're going to practice some implicit differentiation, but now doing that with trig functions. So if you want to flash back section 23.8 where we first talked about implicit differentiation, but I'll remind you of the key idea that we're going to need here. So if you take a derivative with respect to x of something like 3x squared, you'd say, okay, we're just taking our usual derivative and we get 6x. But if you take the derivative with respect to x of something like 3y squared, now all of a sudden there's a chain rule involved. So you take the derivative of the outside function, that would give you 6y. But then you'd say, well, y is our inside function. We need to multiply by dy by dx. So that's really the main thing to remember with implicit differentiation, is that every time you differentiate a y term, just multiply this extra factor of dy by dx at the end of the expression. Okay, so we're going to put that into practice here. The problem is to find dy by dx given some equation in which x and y are all tangled up. So our equation is going to be sine of xy plus cos of 3y equals x cubed. All right, so anytime we take the derivative of an x term, things are normal. Anytime we take the derivative of a y term, we multiply by dy by dx. So let's try it. So first thing we're going to see here is a chain rule. We're going to take the derivative of the outside function, so sine becomes cos, keep the inside function the same, and then we need to multiply by the derivative of the inside function. So I think we should do that part in our next step. Okay, so that's the first term done. Then we move over to our second term. We go derivative of cos is minus sine. So I'm going to write minus sine, keep the inside function the same, and then multiply by the derivative of the inside function. But because we're doing implicit differentiation, we now need to say times dy by dx, because that was a y term that we just differentiated. Okay, and then over on the right side, derivative of x cubed, 3x squared. So in order to get our derivatives done, what we need to do here is just figure out the derivative of xy. Everything else can just be recopied. So we got cos of xy, and then we'll do some work in the brackets here. So derivative of x times y. Okay, well, according to our product rule, we go our first factor times the derivative of our second factor. Well, derivative of y with respect to x is just what we're calling dy by dx. And then we go plus, and we do it the other way around. So second factor times the derivative of our first factor. Derivative of x is just 1. Okay, and then the rest of this is just cleaning up. So this term here would look a little bit better if we write the 3 at the front. So let's say minus 3 sine of 3y dy by dx equals 3x squared. So if you remember how implicit differentiation works, now what we want to do is solve for dy by dx. So that means expanding out, we're going to multiply cos of xy with this term and then with that term, and that way we'll be able to separate all the dy by dx terms from the other terms. So we're going to have x cos of xy times dy by dx, and then plus y cos of xy minus 3 sine of 3y dy by dx equals 3x squared. Okay, now just a point on notation here. When you write something like cos of xy, it's optional whether you want to bracket that or not. If your two quantities are multiplied together, then it's understood that the trig function applies to the entire thing. So it's up to you to decide whether you think cos of xy looks better bracketed or unbracketed. It means exactly the same thing. And we could say the same thing over here. You could write y cos of xy, that's clear, or you could write y cos of xy. Really just a personal choice there. I think because there's a lot going on in this equation, I'm going to prefer to keep it bracketed. All right, so let's get dy by dx terms on the left. We'd have x cos of xy times dy by dx, and we've got another one, minus 3 sine of 3y dy by dx, and other stuff goes right. So 3x squared minus y cos of xy. So then what we can do is factor on the left side, just pull out that dy by dx. We'd have x cos of xy minus 3 sine of 3y. See, as the expression becomes simpler, I tend to drop the brackets around the, or the brackets that are beside the trig function. They just seem to become less necessary as the expression gets simpler. And on the right side, 3x squared minus y cos of xy. So final step here, we're going to divide through dy by dx equals 3x squared minus y cos of xy over x cos of xy minus 3 sine of 3y. So this last problem was a challenge one because it was multi-concept. It brought us back to the idea of implicit differentiation, and it also helped us practice our chain rule and derivatives of our sine and cosine function. So that is all about derivatives of sine and cosine functions. Thanks for watching.